So now let's move on to talk about gross accounting, which is a decomposition approach to roughly identify the contribution of different factors of input in the production process. For example, if capital and labor are the only factor of the input, then the gross can come from the gross of the all factor inputs, that is the capital and labor. In addition to that, the production efficiency or the productivity improvement will also affecting the output, because for the economy that is less productive, then when they put in 2 units of capital and 2 units of labor, they can only produce 2 units of output. But for the economy that is more productive, that is, for example, that when they also put in 2 units of capital and 2 units of labor, they can produce 200 units of the output. Then, to describe the contribution of the performance of an economy, it will be either the economy putting more input, or it could be the production efficiency of the economy is higher. So then we want to adopt the approach called gross accounting to help us decompose the output growth into the growth of all the factors of input and also the production efficiency improvement. So now let's first take a look at what is gross accounting. So to begin with, we define the formula as follows. We say that the changes in the output equal to the changes in the production efficiency plus a parameter alpha k multiplied by the growth in the capital, and then the parameter alpha L multiplied by the growth of the L. So in here, we assume that the capital and labor are the only input for the production process. And then in here, the alpha k is the elasticity of the output with respect to capital. In US, this number equal to 1/3. Under the Cobb-Douglas production function, it is equivalent to capital share. For alpha L, it is the elasticity of output with respect to labor. In US, this number is approximately equal to 1/3. And again, if it is under the Cobb-Douglas production function, this value is approximately equal to the value of the labor share. So then for the gross accounting, the decomposition is based on this formula. It says that the growth of output will equal the growth of the productivity improvement plus the growth of the capital weighted by the elasticity of output with respect to capital, and then the growth of the labor weighted by the elasticity of the output with respect to labor. So then we will be able to decompose the growth in output into the growth in productivity, capital, and labor. So in fact, for this formula, the formula is valid regardless of the assumption of the production function. However, if you are having Cobb-Douglas production function in mind, then it will make this equation digest more easily. So let me illustrate to you why this equation can look like this based on a special example of the production function, which is the Cobb-Douglas production function. So now let's take a look at the Cobb-Douglas production function. We say y is equal to a, which is the productivity, multiplied by the k to the power of theta, L to the power of 1 minus theta. So then if we assign date for each variable under this equation, and then take log, then we are going to have log yt equal to log at plus theta multiplied by log kt plus 1 minus theta log lt. And then of course we can rewrite this equation, assign a different date, which is t plus 1, and then we are going to have the second equation. Then we can take the first equation out of the second equation, that is log yt plus 1 minus log yt. And then we are going to have log at plus 1 minus log at plus theta multiplied by log kt plus 1 minus log kt plus 1 minus theta multiplied by log lt plus 1 minus log lt. Given that the log difference is equivalent to the growth in the variable, so then the left-hand side of the equation can be replace with the growth rate of the y, and the log difference of the a over time will be the growth rate of the a, which plus theta multiplied by the growth rate of the k, and then plus 1 minus theta multiplied by the growth rate of the L. So then we can replace the G here with the delta concept, which is delta y over y, capture the concept of the growth rate in y, will equal to the growth rate of the A plus theta multiplied by the growth rate of K plus 1 minus theta, the growth rate of the labor. In here, the growth rate of labor is represented by delta over L. So this is exactly the formula we have above here. And then what I show you in here is that if we think about the Cobb-Douglas production function, then this equation can be easily understood. That is, the growth in the output equal to the growth in productivity plus the alpha k multiplied by the growth in the capital plus the alpha L multiplied by the growth in the L. And then we can extend this concept into the more general form of the production function, and this equation still holds. So then once we have this equation, we get all the data, and then we will get to know what percentage of the output growth come from the growth in productivity, what percentage of the output growth come from the growth in capital and labor. So then based on this equation, we will be able to come up with the percentage contribution of each factor in output growth. And then so there are 5 steps for growth accounting methodology. The first step is that we need to get the data on output growth, capital growth, and labor growth. But how to come up with the growth for the production efficiency? Well, what should be the good measurement for the production efficiency? It turned out that we do not have the good measure for that. Given that we have the growth in output, growth in K, and growth in labor, and then once we estimate the elasticity of output with respect to capital and labor, that is alpha K and alpha L, and then we will be able to get alpha K multiplied by the growth of the K, alpha L multiplied by the growth rate of L, and then given that we have all the variables number for the equation except the growth rate in production efficiency, therefore we can infer the growth rate of the production efficiency from the equation. If you may recall from the earlier that we said the growth in the output equal to the growth in the productivity plus the elasticity of output with respect to capital multiplied by the growth rate of the capital plus the elasticity of output with respect to labor multiplied by the growth rate of labor. So then after we rearrange the equation, we are going to get that the growth rate of the production efficiency equal the growth rate of output minus alpha K multiplied by the growth of K minus the alpha L multiplied by the growth rate of the L. So then once we have the numbers for each component, then we can compute the percentage contribution of each to output growth. And that is how we use growth accounting to help us preliminarily identify what is the major contributor for economic growth.
So now let me give you a couple examples about how to come up with the contribution of each factor from the growth accounting. The first example I want to show you is the textbook example. The first step is that to come up with the output growth, capital growth, and the labor growth. The second step is that to use the data to estimate the elasticity of output with respect to capital and labor. And then the third step is to come up with the contribution of the growth of the capital and labor, which is the multiplication of the elasticity of the output with respect to capital and labor and multiplied by the growth of the capital and labor respectively. And finally, we compute the productivity growth rate, which is the output growth minus the contribution of the growth of the capital and minus the contribution of the growth of the labor, and then the residual will be the productivity growth. Then later on, the last step is that we can compute the percentage of contribution of each component to the output growth. So let's take a look at the outcome of this growth accounting. Okay, so here's the example for using the US data to come up with the contribution of each factor to the output growth. So as you can see in here, for the US, that the total input growth was about 2%, even though that in 1973 to 1982 was lower than 1948 to 1973. But somehow this number is even higher than the periods 1929 to 1948. That is the first column. So then we may ask, why when we look at the total output growth during the 1973 to 1982, which is on the third column, was much lower than the earlier period. So then we zoom into the productivity growth, and then we find out that the productivity growth turned out to be negative during 1973 to 1982. So it's quite obvious that the reason why during 1973 to 1982 the total output growth rate falls is because the productivity growth becomes less. So then people may ask, why during 1973 to 1982 the productivity growth falls? To answer this question, you may ask, then why during all the other periods the productivity has been kept above 1%? Well, if you look at human history, you will know keeping the productivity growth above 1% is not that easy. And it turned out that in 1950s and 60s, because of the adoption or the beginning use of the electronic devices and the petrochemicals, so then there were rapid growth before the 1970s. But then the economy somehow faces the bottleneck in the 1970s to 80s, that there is no new innovation continues. Therefore, during 1973 to 1982, the productivity growth was relatively low. In addition to the slowdown of the technological advancement during that period, causes the slow growth in productivity growth. What we learned before we know, during 1970s, there are two oil crises, which causes the high rise in the oil price, which may causes the misallocation of resources, which will also causes the slowdown in the productivity. So then what happened after the 1980s? In the 1980s, especially after the 1990s, we find out that there are new development of the internet, cell phone, and also nowadays it may be the artificial intelligence and self-drive cars that may be the next step of the innovation happen in the human history. Therefore, the productivity growth after the 1980s bounced back to the 1% level. So now let's take a look at another example, which is about the implementation of growth accounting on the sources growth of the East Asian countries. This is the result based on Owen Young's paper in 1995. As you can see in here, we not only computed the contribution of the labor growth, capital growth, and productivity growth in numbers, we also compute the percentage contribution of each on the total output growth. As you can see in this table, you will see that the add up of the contribution of the labor growth and the capital growth exceeding 50% for all these East Asian countries for their growth in the 1960s to the 1990s. Therefore, in his paper, he argues that the sources of growth for these East Asian countries are mainly due to the increment in their factor of input, not due to the increase in the productivity. Well, then, do you believe in that? It turned out that a lot of scholars do not believe in that. So then there were a big debate in the literature about what is the source of growth for Hong Kong, Singapore, South Korea, and Taiwan. It turned out that when using different approach to address the same issue, people find out that the contribution of the productivity growth to output growth in these economies should be higher than suggested by Owen Yang. In fact, I also joined this debate in my research, and I find out that in the earlier period of development, it is true that the growth can be somehow sustained by the increase in the factor inputs. However, in the later period of the development, were there no productivity growth, the rapid growth cannot be sustained for these economies.